Sure. So today we're going to talk about the area of irregular shapes. All right, everything's going to be two-dimensional. We'll include rectangles, circles, some parallelograms, some triangles. Will be some shapes you'll see. Let's take a look at this. Here's our first shape here. This is an irregular shape. It's made up of two shapes here. It's made up of a triangle and a square. All right, so so in order for me to find the area here, I'm going to do what? Find the area of so I'm going to put a sub t here, that's my total area. So I need the area of a triangle, I'm going to denote that like that way, and I'm going to do the area of a square. All right, so a couple pieces of information, how do you find the area of a triangle? Well, we need to know that the area of a triangle is,
1/2 base times height.
Awesome, 1/2 base times height. And then the second one is the area of a square, and what's the area of a square? You can use length times width. Some other formulas would just use side squared, or length times width if it's a rectangle. Both of those would work perfectly. All right, so I'm going to figure out the length, the base and height of the triangle first. What is the base? What is the height of my triangle? So the base is going to be all the way across here, and these two marks here, these two tick marks mean that this is 2 and this side is 2. So what will be the total length of that base? Yep.
17.
Yeah, so this is 13 because this is a square. 13 plus 2 is 15. 15 plus 2 is 17. So my base is 17, and then the height is going to come from the vertex and come straight down and make a right angle. What is that height there? Yep.
5.
Okay, so if you have total here of 13, and then the total is 19, then this must be the difference of 19 and 13, which is actually 6. Right? Because then 6 and 13 will give you 19, and this height will be 6. So now I can find the area of the triangle. So I'm going to get that one out of the way. So 1/2 base times height. 1/2 times 6 is 3. 3 times 17 is 51. Okay. And I get 51 meters squared just for that top triangle. And then my area of the square here, the side length here is actually 13. So on that side is 13. Let me just backtrack that a little bit. Fill that in. So the side length is 13. So the area of the square here is going to be 13 times 13, or 13 squared. And 13 squared is equal to, yeah, awesome, 169. And then the final piece here, so I found the area of the triangle, found the area of the square, and then the total area, so I'm just going to denote that by a sub t, is actually going to be 51, which is the area of the triangle, plus 169, which is the area of the square there. And if I add the two together, 169 and 51, I got a total area of 220 meters squared. Find its entire area to the nearest tenths. So again, I'm going to say a sub t is my total area. What shapes do I have here? I have a, I have a rectangle, and say that, and I have the area of half a circle. Okay, so what is the area? So I'm going to look at these separately. What is the area of a rectangle? Area of a rectangle is?
Length times width.
Awesome, length times width, and I have the length, and I have the width of the rectangle. The length and width are?
6 and 20.
Yeah, 6 and 20. Doesn't matter which one's which. So I can find that area. And then I have the area of half a circle, so 1/2. And what's the area of a circle? So I only want half of it. But what is the area of a circle? Yep. Yeah, so pi r squared is the area of the circle, but I'm only going to take half of it. That's going to denote that piece. And I need here, the only missing piece here is my radius. So the radius is not given directly, but what is the radius? How can we figure out the radius? So if here's my circle, there's the center, what's the radius? Yeah, the radius is actually 3. If the whole if you take this measurement all the way down, this whole thing is 6, which represents the diameter. So if the diameter is 6, then the radius here is 3. Awesome. So now I have everything I need to find the total area. So I'm going to say A sub t is equal to 20 times 6, which is the rectangle, plus 1/2 times, now it says round to the nearest tenth, so we're going to let pi equal, we're going to assume pi is equal to 3.14, just for estimating purposes, times 3.14. So let's plug that in. And then times my radius squared, which is 3 squared. And you can do this piece by piece, or if you want to, you could do this entirely in one keystroke into your calculator. You could just put 20 times 6 plus 0.5 or 1/2 times 3.14, and then times 3 squared or 9, and you'll get a total area of 134.13 and 134 and 1/10, rounding to the nearest tenths, meters squared. The area of the shaded region here, the shaded region being the blue region here. This picture is a little tricky, but not too bad. So what's the visual here? What do we see? Do we see any cutouts or, yep. Okay, looks like a diamond, yep. Yeah, quarter circles sound great. So I'm going to take this little diagram here and I'm going to put that there to give you that visual. So really I just cut out a quarter of a circle from each corner. Well, what's a quarter, quarter, and a quarter of all the same radius? It's just a whole circle. So what I have here is just the area of a square. So my a sub t, I'm going to go with a sub t again. My total area is the area of the square minus the area of a circle. And that's pretty much the whole picture right there. Right, so the total area of this shaded region is going to be the square, the entire square, minus the one entire circle. All right, so if I'm going to go with the area of the square is equal to side squared. The area of the circle, again, is equal to pi r squared using our formulas. What is the side length of the square? 9. What is the radius of the circle? So remember, the radius is coming from here to here. So what's the radius of that circle? Yep. So it comes from, so the entire thing is 9, and it's coming about halfway of 9. So what's half of 9? You got it. So this would be 4.5. Alright, so now I have the side length of the square, I have the radius of the circle, so my total area is going to be 9 squared, minus this time, I'm taking those pieces away. I'm going to use, again, let pi equal 3.14, so it's going to be 3.14 times 4.5 squared. Alright, again, this could be one keystroke on your calculator, so 9 squared minus 3.14 times 4.5 squared on the calculator, and you should get an answer, a grand total of 17.4, rounding to the nearest tenths, and again, meters squared, because it's talking about area. Area of the shaded region, we have the purple region, and round to the nearest tenths. Alright, so the visual here is probably the most challenging part here. So we have a yin-yang symbol here, but what do we actually have here? So I'm going to take a look at this. I'm going to drag this in here. I want you to get this visual here. So if I took that shaded region of that part there and cut it out, rotate it, and paste it in here, I would actually be filling up half a circle. So the area here, the total area here, is just going to be 1/2 of a circle, or 1/2 times pi r squared. The radius here is not given directly. The diameter is given. From here to here is 5. So from here to here is the radius. So the radius would not be 5, but the radius will be half of that, or 2.5. So here's my 2.5. So area 1/2 times, I'm going to let pi equal 3.14, and hopefully that's given to you guys. 3.14 times 2.5 squared. Again, one keystroke, so I would do 0.5 times 3.14 times 2.5 squared on my calculator here. And hit enter, and you should get a total area of 9.8125 or 9.8 rounded to the nearest tenths inches squared. Here's the figure again. Find the entire region. This one could be a little tricky. You might take this one a little differently. So what shapes do I see? So I'm going to drag in some shapes here. So this is what I actually see here. I see a rectangle. I also see a parallelogram. And then lastly, I see a square. So my total area here is going to be that of a rectangle plus the area of a parallelogram, and then plus the area of a square. All right, if I broke that down into three different shapes. The area of a parallelogram is just base times height, so I need a base and height here. I'm sorry, of a rectangle is length times width. Let's erase that. I need a length here, a width here. What's the length and width of this rectangle? Length and width of this rectangle is going to be,
50 and 15.
Yeah, 50 and 15. I'm going to take the area of a parallelogram, which I'm going to need base times height for a parallelogram. What's the base and height of this parallelogram? 40 is the base, and what makes the right angle? That's always going to be the height, and that'll also be 40 as well. And then the last one is a square. All I need is one of the sides here. That looks like a 5. I just need one of the sides here. So what's the side length of that square? Yep. And that side length is 10. Awesome. So then here I have area total is equal to length times width, or 50 times 15, plus base times height, and then side squared, and plus 10 squared or side squared. So I got 50 times 15 plus 40 times 40 and times 10 squared, and I get a total of 160,750 centimeters squared. Actually, that's incorrect. Let's retract that statement, and 24,500. Made that one of those plus signs, multiplication sign, so this is 2,450 centimeters squared.